All right, hello everyone. In this session, I'm going to go through the exercise part that I hinted at yesterday in the CEDAR tutorial. And for this, most of the time I'm going to share my screen. This time I'm actually going to go through the entire thing and build that so that even though you may not have done it, you can kind of see what this is about. So I'll share my screen here. And you should now see the website of the summer school. There's a bunch of stuff going on in the forum, which is quite nice. So we're talking about, if you go to documents and down here in the CEDAR tutorial, this is actually the video that I recorded yesterday. And then here is the exercise. If you open this PDF file, most of this I covered yesterday, and we went up until here. So I did these 3 different fields. And now I'm going to cover this task, the exercise task, in which I'm going to build, let me close this for a second. Okay. So we're going to build this little architecture here, which uses the elements that we've put together yesterday into a small architecture that does at least a little bit of a function. And it gives you a hint at these more complex architectures that we're going to talk about in the rest of the summer school. It's actually like a small version, a very much simplified and small version of the spatial language architecture, where we took out most of the more complex things that you'll still learn about. So we'll do this in CEDAR. Again, I'll start this here by just starting the CEDAR App file. There we go. And then I'm going to build this little thing. It starts with this scene representation field, which is a 2-dimensional field that keeps a representation of the different objects. And again, we're going to use simulated input, which says here scene input. So we're going to build this from Gaussian inputs. So let's build that in the beginning. Put that here. We'll use a field here, and we can already call this scene representation, and not worry about the parameters for now. And then we'll build our little scene with 3 Gaussian inputs, so that we have 3 different objects. And like yesterday, we can plot these, and then change the position of the object. So we'll put one in the top left corner, maybe here, and there, and we'll actually call that top left because later on maybe we want to switch them on and off again, and then we know which one is which. And the second one, we take that and we put that maybe in the bottom left. We call it bottom left, and move it to maybe to here. This is not in the bottom left. And the third one, we'll put that bottom right, and move it to here maybe. Okay, so these are our 3 objects. And then to have a scene, we sum all of these up. So if we plot this now, you'll see this is now our little scene. And then we multiply that so that we have an ability to adjust the strength of the entire scene. We'll look at that later. So now if we put this as an input into here, and we plot what the scene is, what the field is doing, we also have to start the simulation, otherwise it's not doing anything. Then we can adjust the strength of the scene until there are peaks in this field. So we bump this up here maybe to 6. And then we have these 3 peaks in the field. Right? So far so good. This is basically what we had yesterday. And then if we go back to the document, so we've built this part. And now we want to build another field, which in the end is going to be selective. And the idea here is that this field is going to make a selection decision, which is also biased at the same time by another input. I call this the region input here. So it's biased toward objects that are on the left or the right, depending on what kind of regions you built in here. And this region input, we're also going to use Gaussian inputs for this, but let's maybe first build the field. So we need another field, drag this down from up here, and we call this then spatial match field. And then of course we need some kind of connection, and we have, you know, the synaptic strength. Again, from this field, we set this to a different value this time. So the idea behind this field is that it only creates a peak if there's input both from the scene representation field and also from this region input. And if these 2 inputs overlap, only then should that peak, should that field create a peak. Otherwise, it shouldn't. So we have to make sure that with input from just the scene representation, it does not create peaks by itself. And we can, that's already the case here. We'll make this a little bit stronger. So we put that to 3. Now the activation here is at -2 at the maximum. So we need a little bit more from these region inputs to bring them above threshold. So now we add these region ideas. So we add Gaussian inputs here, and we'll basically build, let's say, 2 of these regions on the left side and on the right side. And maybe you've done different ones, but we'll just do that. And we call this one left. Oops, left. And now we plot this and look at what it looks like. So we have to make this, if it really is supposed to be the left side, it has to cover much more area. So we will, I know that some parameters down here. There. So first, the amplitude needs to be strong enough so that it creates a peak here. We can do that later. We have to move the centers over a little bit so that it's actually on the left side, and then we have to make it much wider. So we make this like very large in this dimension, and then wider as well, maybe like this. And this is now, you know, covers the left side, let's say. And then we do the same thing for the right side. And if we plot this, make it the same size. So this is what I had before. And I think it was 13, yes. And move it over to here. Right? Now we have left and right. And now we can, if we connect it here, we can activate these inputs, and then by doing that, saying we're now looking for something on the left or on the right side of our little table that this field is representing, right? We still have to make sure that the strengths are right. So we'll turn one of them off completely, the right one. And the left one, we can add that here and already look at what that looks like. So if we plot the spatial match field, it now looks like this. So this is the activation, and you'll see that there is input from the scene representation. So these dark red blobs here are subthreshold inputs that represent these 3 objects. And then you also see that it's a little lighter here on the left side, which comes from this region input. And you also see that there is no peak in this field. And this is because the input from this region input is still not strong enough. You can also see that the activation here at maximum is still below threshold. So we increase this until there are peaks here. And you can see that, you know, if we bump this up to 3, we now have selected these 2 objects on the left side. So that's nice, and we can do the same thing later with this region input from the on the right. We can actually do that now. So if we turn this back off to turn this to 0, and we connect this here and bump it up to 3, you can see that it's then selects this other object here on which is on the right side. Right? And so with this mechanism, by hand, we can now select objects that are in a certain region within that space. So let's maybe look at the left side. And what we also want is for this field here to make a selection decision. So we only want a single object which is on the left, and currently there are 2 objects which match this region. So we can now tune this spatial match field to make a selection decision. And we covered how to do that in the CEDAR tutorial. So if we look at the parameters of the spatial match field, we know that for a selective regime, we need lots of global inhibition. And I'll just use the parameters that I used before. So minus 0.3 for the global inhibition. And you also saw once I did this, there's basically no output anymore because everything is suppressed. So we need more self-excitation and good parameter value. So you can just ramp this up here, and at some point you will see that something comes up. Good values actually for this is 25. And now we have a field that makes a selection decision, right? And what it actually also does is pick the object that best fits this region. So you can see that the peak is now at the bottom one of these 2 objects which are on the left, because it's actually more toward the center. So this is a selection instability, and this bottom one wins because from the beginning it has a little bit higher activation because it overlaps better with this template. And we can see that this works now if we remove objects from the scene. So if we take the bottom left object, which is this one, if we take that out, so we say 0 here. Oh, this is top left, sorry, bottom left. You take this one out, you should see that this makes another selection decision and now creates a peak up here. Right? Now if we put that back in, this is now hysteresis, right? Now the peak is up here, which is what we would have expected. Good, and then in the exercise sheet, we wanted one more field, basically just to have another, working memory field in there, and we'll put that in. So we add a new field, and we call it working memory. Working memory. And we want it to be, first of all, we wanted to get some input. So in a way where it always builds a peak when there is some input coming in from here. So the strength of this must be strong enough, let's say 6. You can already see that it has created a little peak there. Let's move this over a little bit. And then look at this plot. So you can now see that there is, let's move it a little more. There is no peak in this field, but we also want it to be in a regime where that peak is sustained. Because right now, if I took the input away, if I did this, then the peak would disappear, and we want it to stay. So we need a lot of, first of all, a lot of self-excitation. And if we want multiple peaks in the end, we also want mid-range inhibition. This is also something that I covered in the CEDAR tutorial, how to tune this. So first of all, we turn off the global inhibition. And then we need two kernel modes, one excitatory, which we already have here. So we add another one, which is then going to be inhibitory. Right, so this is the excitatory part. This is going to be inhibitory, so it'll be negative. And then now we just have to find, and it's going also be going to be broader. So let's so the excitatory part is always going to be a little slimmer. The inhibitory part is going to be broader so that you get this Mexican hat kind of shape. And then we only have to find the amplitudes, right? So what we can do is, ramp this up here, and then I went through how you can detect whether this works or not. You can always deactivate the input and then see, does the peak stick around? It doesn't. So in this case, we need more self-excitation. If you have too much self-excitation, this field is going to go above threshold everywhere. So then you need more inhibition. So I'll just skip over this and say you need a lot of self-excitation and even more inhibition. And then if we reset this, we have peaks now that that are self-sustained. So if I take away the input like this, you now see that there's no longer any input to this field, but the peak sticks around. Right? And one thing that we can now do is, if we reset the entire architecture and put still some input in here, you now see that the spatial match field made a selection decision for the bottom left object, because we still have this region input on the left side, and this one is stronger. And the working memory field now has a working memory representation of having selected that object. And if we now deactivate or take away that object from the scene, so that's the bottom left one. Let's see if I'll make this right. So bottom left, we deactivate that. What we should see then is for the spatial match field to make another selection decision for the one on the left. And that should then also be represented here in the working memory field, right? So let's see if that works. We take this out. We have our selection decision here, and it's then added to this working memory field. So now we have a representation of having first select this one and then this one. We can now, if we also want the third object in this field, we could, for instance, deactivate this region input on the left side. Say maybe we don't want this anymore. Go down to 0 here. And then activate the one on the right side. And this should then create a peak in the spatial match field, which then flows over here to the working memory field and creates a peak there. There's a peak, and there's the self-sustained version. So this is our little architecture. And what you'll notice is that a lot of this is still kind of flimsy. It works with simulated input, and we can change that. It's also a bit strange that all of these objects are just simulated. They don't have any feature. Maybe later on we want to do real visual search for features. One thing that you'll notice is that we are applying these region inputs always to the image. One thing that you may want to do is say, where is the object that's to the left of this other object? And that amounts to being able to apply these regions to all parts of the image. And that's something that we could do here if we change the synaptic weights and move these regions around. But that would actually mean changing synaptic connectivity. And we'll show you in the next kind of lectures how to do this with coordinate transforms, so that you're able to say, is that to the right of a position here? And then this spatial region should only be applied to this little region over here. And then one thing, you could also think of other kinds of regions or other kinds of spatial or relational ideas. These are now spatial, right? They say this is on the left side or on the right side. There are other such relational concepts which have to do with movement. For instance, if you have a dynamic scene, you could ask for, is this moving toward an object or is it moving away from? These kinds of things, and I'll talk about that, I think, tomorrow. And one of the largest issues now here is that in order for this to do something, I'm actually, as a user, going in there and activating things and deactivating things, and then you get some kind of behavior out of it. And what we really want is for this system to maybe get some input from the camera or so maybe some language input, and that it then acts autonomously. So it does things on its own. It goes through different sequences, different kinds of steps, all the things that I did by hand, by like activating this region or removing objects and these kinds of things, that the architecture does that on its own. And we'll cover that too. And that then brings these architectures toward autonomous behavior. There's one thing that I wanted to do, which is not in the exercise sheet. I wanted to show you what it would look like if we replace the simulated input that we've been using with real camera input. So actually, I'm not going to use a camera, but I'm going to use a video file, which in the end is also going to be static, but just to show you that this actually works. So I have prepared this here, and I'll upload this file also to the website so that you can play with it. So what I've built here is this part of the architecture is the same as before, slightly different parameters, I think, because the input is a little different. But then in front here, there's a whole bunch of steps. All of this is in part algorithmic pre-processing of this video file. So the video is actually, an actual video that is looped, but it's a static scene that looks like this. So if I run it, this video now runs. You can see, maybe, probably not, but there's a little bit of noise in here. And I do have videos like this where these balls are moving around. It's a very simple scene, white background and so on, and then a bunch of different processing steps here that cut away part of this image, so we're not interested in the borders. So the resulting thing looks like this. It resizes it a little bit and does then some magic to get an activation distribution which looks like the things that we built with our Gaussian inputs. So the input into the field, if you then look at the last step here, it's plotted a little, I'm not sure why it's black and white, but the input then looks like this, right? We have this kind of video, and then highly saturated parts of the image, like these different balls here, the red and the green color are more saturated than the white background. This then is, very simple representation of what that camera image holds. And that then goes into the scene representation field here. So you can now see that there are 3 peaks, and these are fed by the camera input. And then we have the same kind of architecture. We have these, oh, this one seems to be off. We have these region inputs on the left and on the right. We have the spatial match field, which in this case, since it's getting input from this region on the right, is creating a peak and making a selection for this. Maybe open the camera up. This object here on the right side. And then we also have the working memory representation which has a self-sustained peak. Right? This, using this video file now has the downside that you can't quickly change the scene, so I can't show you that this actually does something different, unless actually that's not true. If I activate the other region input, so I deactivate this one and I activate that one, the one on the left, I now have gotten selection decision for the one on the other side, which then is also loaded and sustained here in the working memory representation, right? I've tuned these region inputs a little differently so that this green object in the center is not covered by them, which is just for this scene. So now maybe that gives you an idea of how to use actual input from a camera, even though this is very much simplified, right? So I'll put this file online. You can play with this. I'll also put this little video file online. And also the solution to the exercise that I just produced. I have a file for this that I'll put online, and you can play with these things. And if something is unclear, ask questions about that. And this is also beginning to go toward where some of these CEDAR projects go. They have some kind of input from a camera, and then they have a visual search architecture which is able to look just for red objects, just for green objects. This is the first kind of thing that you work on. And then we have a project on spatial relations, spatial language, where we can match it to different regions within the entire space. And we have other projects that work with the simulator robotic arm and build these bit more complex architectures. This is what we're going to introduce at the end of today. We'll talk about the project work that everybody can work on if you're interested, even if you're not in the workshop per se.